Is it possible to create something out of nothing? Or more precisely, can energy be made into matter? Yes, but only when it comes together with its twin, antimatter. And there's something pretty mysterious about antimatter. There's way less of it out there than there should be. Let's start with the most famous physics formula ever, E equals mc squared. It basically says that mass is concentrated energy, and mass and energy are exchangeable. Like two currencies with a huge exchange rate, 90 trillion joule of energy are equivalent to 1 gram of mass. But how do I actually transform energy into matter? The magic word is energy density. If you concentrate a huge amount of energy in a tiny space, new particles will come into existence. If we look closer, we see that these particles always come in pairs, like twins. That's because particles always have a counterpart, an antiparticle, and these are always produced in exactly equal amounts, 50-50. This might sound like science fiction, but it's the daily life at particle accelerators. In the collisions between two protons at CERN's Large Hadron Collider, billions of particles and antiparticles are produced every second. Consider, for example, the electron. It has a very small mass and negative electric charge. Its antiparticle, the positron, has exactly the same mass but a positive electric charge. But apart from the opposite charges, both particles are identical and perfectly stable. And the same is true for their heavy cousins, the proton and the antiproton. Therefore, scientists are convinced that a world made of antimatter would look, feel and smell just like our world. In this anti-world, we may find anti-water, anti-gold and, for example, an anti-marble. Now imagine that a marble and an anti-marble are brought together. These two apparently solid objects would completely disappear into a big flash of energy equivalent to an atomic bomb. Because combining matter and antimatter would create so much energy, science fiction is full of ideas about harnessing the energy stored in antimatter, for example to fuel spaceships like Star Trek. After all, the energy content of antimatter is a billion times higher than conventional fuel. The energy of 1 gram of antimatter would be enough for driving a car 1,000 times around the Earth, or to bring the space shuttle into orbit. So why don't we use antimatter for energy production? Well, antimatter isn't just sitting around, ready for us to harvest. We have to make antimatter before we can combust antimatter. And it takes 1 billion times more energy to make antimatter than you get back. But what if there was some antimatter in outer space and we could dig it out one day from an antiplanet somewhere? A few decades ago, many scientists believed that this could actually be possible. Today, observations have shown that there is no significant amount of antimatter anywhere in the visible universe, which is weird because, like we said before, there should be just as much antimatter as there is matter in the universe, since antiparticles and particles should exist in equal numbers. This missing antimatter, now that is a real mystery. To understand what might be happening, we must go back to the Big Bang. In the instant the universe was created, a huge amount of energy was transformed into mass, and our initial universe contained equal amounts of matter and antimatter. But just a second later, most matter and all of the antimatter had destroyed one another, producing an enormous amount of radiation that can still be observed today. Just about 100 millionths of the original amount of matter stuck around, and no antimatter whatsoever. Now wait, you might say, why did all the antimatter disappear and only matter was left? It seems that we were somehow lucky that a tiny asymmetry exists between matter and antimatter. Otherwise, there would be no particles at all anywhere in the universe, and also no human beings. But what causes this asymmetry? Experiments at CERN are trying to find out the reason, why something exists and why we don't live in a universe filled with radiation only. But so far, we just don't know the answer,